All right, listeners, today we're diving into a paper that kind of flips the script on how we think about student knowledge in AI.
Oh, yeah.
It's called Uncertainty-Aware Knowledge Tracing,
Okay.
and it tackles this really cool question.
hmm
Can we actually teach AI to understand not just what a student knows,
Right.
but how confident they are in what they know?
Yeah, that's a fascinating shift because,
Yeah.
traditional models have always kind of looked at knowledge as very black and white. Like
Yeah.
you either get the answer right or you don't.
Exactly.
But as anyone who's ever, crammed for a test or
Oh, yeah.
tried to teach something to somebody else knows, learning is so much messier than that.
For sure. It is, and this paper actually points that out.
Yeah.
There's some really good examples, like you can make a careless mistake even if you know the concept.
Right.
Or you might just get lucky and guess correctly
Yeah.
when you're totally
You
lost.
just happen to get it right.
Yeah, and those older models they couldn't handle that.
They don't pick up on all that nuance.
Totally.
Yeah.
So how does this UKT model,
Yeah.
which stands for Uncertainty-Aware Knowledge Tracing,
Huh?
how does it tackle this challenge?
Well, it's a pretty big jump from just right or wrong answers.
Yeah, it seems like it.
So instead of just assigning a single point to say, okay, this is what the student knows,
Right.
it uses this thing called a Gaussian distribution.
Okay.
So think of a bell curve,
Mhm.
the middle of that curve, the mean that represents their kind of overall knowledge level.
Okay.
But the width of the curve, the covariance,
Yeah.
that shows us how uncertain they are.
Interesting.
So a wide spread out curve
Hmm.
means there's a lot of variation in their answers.
Okay.
Maybe they're prone to guessing or,
Yeah.
just kind of all over the place.
Yeah.
But a narrow peaked curve that tells us they're pretty consistent in what they know.
I see. So even if two students have the same average score,
Exactly.
the model can tell us
Yeah.
if one is consistently solid
Right.
and the other one maybe is just,
More prone to guessing or making silly mistakes.
just kind of all over the place. Yeah.
Exactly.
That seems really valuable for personalized learning
Oh, absolutely.
recommendations.
Yeah. And it gets even more interesting
Oh, does it?
because they use this method called the Wasserstein distance
Okay.
to measure how these distributions change over time.
Interesting.
So instead of just comparing 2 points, okay, you're at this level and you're at this level,
Right.
it actually compares the shapes of those bell curves.
Wow. So we can see a student's understanding evolve over time,
Exactly.
taking into account how consistent they are, or their tendency to guess.
It's like watching someone's grasp of a topic come into focus as they're learning.
That's amazing.
Yeah.
But I remember the paper mentioned that not all uncertainty is the same,
You're right.
right? There are different types.
Yeah. So they make this distinction between epistemic uncertainty,
Okay.
which is that uncertainty that comes from just not knowing something.
Like a genuine gap in knowledge.
Exactly. And then there's aleatory uncertainty.
Hmm.
And that's due to those more random factors like guessing or careless mistakes.
So the stuff we were talking about before.
Exactly. And for, if you really want to assess how someone's learning,
Right.
you want to focus on that epistemic uncertainty, the real knowledge gaps.
So how does UKT
Yeah.
separate the useful uncertainty from all that noise?
Well, this is where it gets really clever.
Okay.
They use this technique called contrastive learning.
Uh-huh.
And basically what they do is they train the model to tell the difference
Okay.
between, real knowledge
hmm
and just those random fluctuations.
So they're almost deliberately messing it up a little bit.
Yeah. So imagine you take a student's, history of answers and you just flip some of them.
Oh, so you're saying
Some correct ones become incorrect, some incorrect become correct.
no, it's interesting.
And by training on these kind of messed up examples,
Yeah.
the model learns to see through all that noise.
You can tell the real pattern from just the random stuff.
Exactly. It's kind of like giving a detective experience with,
Okay.
real crime scenes, but then also some staged ones.
And they can spot the difference.
Exactly. And that makes it so much better at,
Right.
zeroing in on the student's actual level of understanding.
That's really cool. So how did it actually perform in practice?
Well, they tested it on 6 different educational data sets.
Right.
And it consistently outperformed all the other, state-of-the-art models.
Wow. So it actually lived up to the hype.
Yeah, it did when it came to predicting how students would perform.
So that's a pretty significant accomplishment.
Yeah, definitely.
Was there anything particularly surprising or interesting that you saw in those experiments?
One thing that really stood out to me was how it captured the differences in that epistemic uncertainty
Mm-hmm.
between students who were working on different types of math problems.
So interesting.
Some data sets showed like consistent patterns of uncertainty for individual students.
Oh, so like their way of learning was fairly stable.
Exactly.
Okay.
Yeah. But other data sets showed more variation across students.
So like different people learn in different ways.
Yeah, highlighting just how diverse our approaches to learning can be.
It's almost like the model is revealing not just what they know,
Yeah,
but also like how they think.
exactly. And that's what makes this work so compelling.
Yeah.
It's not just about, building better educational technology. It's
Yeah.
about building AI that actually understands this complex
Yeah,
and beautifully messy reality of how humans learn.
totally. Okay, so before we jump into
Yeah.
the broader implications of all this, let's take a quick detour into our novel Notions segment,
Okay,
where we stretch our imaginations a bit
I like it.
and we think about what if we could apply this uncertainty-aware approach
Yeah,
to something beyond education?
I'm intrigued. Lay it on me.
What if we could use it to model the evolution of scientific research? Like imagine an AI that could track how certain or uncertain we are
Okay.
about different scientific theories
Yeah.
and then highlight areas where like maybe we need more research or
Right.
where a paradigm shift might even be brewing.
Now that's a thought-provoking idea. You could create like a map
Right.
of the knowledge landscape for a specific field.
Exactly.
You could see where the consensus is strong
Mhm.
and where things are still really up in the air.
Totally. And think about how that could impact like
Yeah.
research funding,
Oh, yeah.
scientific publishing,
Mhm.
even just public understanding of science.
Absolutely.
It'd be amazing to see how consensus forms and shifts
Yeah.
and watch new ideas come from the
It's
fringes.
like a living, breathing map of knowledge that's constantly evolving.
Exactly. But before we get too carried away with all the future possibilities,
Right.
maybe we should ground ourselves a bit. Like, where does this idea of uncertainty-aware knowledge tracing
Mm-hmm.
fit into the broader history of AI and education?
Well, the whole concept of knowledge tracing, it's
Mhm.
actually been around for a while.
Really?
It goes all the way back to like the 70s and 80s
Wow.
with those early intelligent tutoring systems.
Oh, right.
But back then, they relied mostly on handcrafted rules to track student progress.
Yeah.
But then as machine learning started taking off
Mhm.
in the late 90s, early 2000s,
Yeah.
researchers started exploring these more data-driven approaches.
So instead of like pre-programmed rules,
Right.
the model could actually learn from the data and
Exactly.
adapt to individual students.
Yeah. So one of the early breakthroughs was this thing called Bayesian knowledge tracing, or BKT.
Okay.
It came out in the late 90s,
Mm-hmm.
and it used a statistical model to estimate the probability that a student had mastered a concept.
Based on their past performance.
Exactly. It was a big step forward, but it still had some limitations.
What were some of the shortcomings of those early models?
Well, BKT, for example, it made some pretty big assumptions about learning. It assumed that all students learn at the same pace,
Okay.
or that once you've mastered something, you never forget it.
Right. And we know that's not true.
Definitely not. It also had trouble handling those complex relationships
Mhm.
that often exist between different concepts.
So it was a good starting point, but maybe a little too simplistic.
Yeah, it was a bit too simplistic to capture the real messiness of learning.
Right.
But then in the 2010s,
Mhm.
deep learning came along and really changed the game.
Oh, yeah. Deep learning was a huge deal.
These deep learning models like recurrent neural networks or RNNs
Yes.
and transformers,
Uh-huh.
they were much better at capturing those complex patterns in the data.
Okay.
And that's where models like DKT and SAKT came in.
The ones that this paper compares UKT to.
Exactly. Those were some of the big players.
Okay.
And they were able to get much higher prediction accuracy
Interesting.
than those older models, and they could handle much larger data sets.
But they were still treating knowledge as this kind of deterministic thing.
They were mostly focused on,
Right.
will the student get the next question right or wrong?
Yeah.
Without really digging into the uncertainty surrounding that prediction.
So they were powerful, but still missing a piece of the puzzle.
Exactly. They were missing that crucial element of uncertainty.
It seems like the idea of incorporating uncertainty
Yeah,
brings us closer to that original vision of intelligent tutoring systems,
I agree.
right? Like creating AI that can truly understand and respond to
Hmm.
how individual students learn.
And by embracing uncertainty, these models can actually offer more personalized and adaptive feedback.
Oh, that's interesting.
Imagine a system that not only knows what a student is struggling with,
Right.
but also how confident they are in their understanding.
So it can tailor the learning experience.
Exactly. It can really target those areas where they need the most support.
It strikes me that this idea of modeling uncertainty could be really useful in other areas too,
Oh, absolutely.
like beyond education.
There are so many possibilities.
Like where the...
We'll take healthcare, for example.
Okay.
Imagine a diagnostic AI that can not only identify potential illnesses,
Right.
but also tell you how certain it is about each diagnosis.
Oh, that'd be huge.
It could help doctors prioritize cases,
Yeah.
avoid unnecessary tests, and make more informed treatment decisions.
That's a really powerful example.
Yeah.
What about like finance?
Oh,
An AI that could assess investment risks
right.
and communicate how uncertain those assessments are.
That could totally change how people invest.
For sure. And what about self-driving cars?
Oh, yeah. A self-driving car needs to know how confident it is
Yeah.
in its perception of the environment.
Right. To make those split-second decisions.
Exactly. It's all about understanding the limitations of its own knowledge.
Yeah, it's not just about making predictions.
Yeah.
It's about knowing when you might be wrong.
And being able to communicate that uncertainty effectively.
Which actually brings us back to our novel notions segment.
Okay.
We've talked about healthcare, finance, self-driving cars. But what about tackling something that feels really relevant right now?
Like what?
The spread of misinformation online.
Ooh, that's a timely one. I'm listening. Yeah, that's a big one these days.
Imagine if we had an AI that could analyze online content.
Okay.
Like social media posts, news articles, all that stuff. Not just to flag things that might be false.
You're right.
But to actually quantify the uncertainty around different claims.
So instead of just like true or false,
Yeah.
it would give you a more nuanced view, like a truthiness score, like a confidence interval.
Yeah, like how much can we actually trust this information?
Oh, that could be really powerful.
It feels like right now, a lot of the fact-checking efforts
Yeah.
are just focused on like debunking specific claims, which feels like whack-a-mole.
It's never ending, right?
Yeah, with how fast misinformation spreads.
Yeah, and sometimes those debunking attempts can even backfire by giving more attention to the very thing they're trying to debunk.
Oh, that's interesting.
It's like Streisand effect. Yeah, I see what you mean.
And sometimes just saying something is false doesn't really address why people might believe it in the first place.
Exactly. So what if we could shift the focus
Okay.
to understanding and visualizing the uncertainty around these claims?
I like that.
It might help people develop that healthy skepticism.
Yeah.
And be more discerning about what they trust online.
It's like giving everyone a built-in BS detector.
I love that BS detector.
Right.
Imagine you're scrolling through your feed
Yeah.
and you see a post with some claim about, I don't know, a miracle cure for something.
Right.
But right next to it, you see this little uncertainty bar
Okay.
that's like maxed out.
Showing you there's no evidence to support it.
Exactly. It could be a little nudge to say, hey, maybe do some more research.
Don't just take this at face value.
Yeah. And think about how this could be used to catch misinformation early on
Oh, sure.
before it goes viral.
Right.
Like you could track the uncertainty levels and see which claims are gaining traction, even though there's no evidence.
Right. It could give fact checkers and platforms more time to respond.
It would be like an early warning system.
Exactly. Catch it before it spirals out of control.
That's a really cool idea.
Of course, there are tons of challenges.
Oh, yeah, for sure.
Like potential for bias, making sure the AI itself doesn't become a tool for spreading misinformation. We don't want that.
Definitely not. And then there are those bigger questions about freedom of speech and censorship.
Right. Those are tricky issues.
Absolutely. But I think it's a conversation worth having.
I agree. If we can use this idea of uncertainty-aware AI for good,
Yeah.
it could really change how we consume information online.
I think so, too. It's about empowering people to be more critical thinkers.
Exactly.
All right.
Okay, so we've explored this really interesting idea of applying uncertainty-aware AI to combat misinformation.
It's a big challenge, but with a lot of potential.
For sure. But now I want to shift gears a bit and talk about the ethical considerations surrounding this whole idea of uncertainty in AI.
Yeah, that's a crucial aspect we can't ignore. It really is, especially when we start talking about AI making decisions that affect people's lives.
Right, like in those healthcare examples we were talking about.
Exactly. Or think about like loan applications or even criminal justice.
Oh, wow. Yeah, the stakes are high.
If an AI system is denying someone a loan or flagging them as a potential risk,
Right.
We need to know how confident it is in that decision.
And how it arrived at that level of confidence.
Exactly. And this is where transparency becomes so crucial.
So we can understand the reasoning behind those decisions.
Yeah, and make sure those systems aren't perpetuating existing biases.
Right, because if the data the AI is trained on is already biased.
Exactly. Then the AI is just going to amplify those biases.
And potentially lead to unfair or even harmful outcomes.
And that's a huge concern, especially as we see AI being used in more and more domains.
It's not just about the accuracy of the predictions anymore.
It's about fairness, accountability, transparency.
And making sure that these powerful technologies are used ethically and responsibly.
It's a big responsibility, but I think it's one that we need to take seriously.
Absolutely. Well, on that note, I think we've reached the end of our deep dive.
It's been a fascinating conversation.
It really has.
Yeah.
We've covered a lot of ground today, from the technical details of uncertainty-aware knowledge tracing
Yeah.
to its potential applications in education, healthcare, finance,
Even combating misinformation.
and the ethical considerations that come with all of this.
It's a rapidly evolving field with so much to explore.
For sure. And I hope our listeners are leaving today with a better understanding
Yeah,
of not just what AI can do,
right.
but also how important it is to think critically about uncertainty.
And to demand transparency and accountability from these systems.
Absolutely. Well, thanks for joining me on this deep dive.
It's been a pleasure.
And to all our listeners out there, keep those mental gears turning, and we'll see you next time.